How do you think we should go about solving this problem? What steps do you take when you have two fractions set equal to each other? Several different ways to do it, just for the record. In my opinion, one best way. So is it okay if I just show you that one? Two fractions set equal to each other, cross multiply. Right? That's what you tried to do the other day, right? When we were multiplying, you wanted to cross multiply, and I was like, no, 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 no. We only do that when two fractions set equal to each other, okay? So if we cross multiply, I have 4 times x plus 6 equals 5 times 2x, okay? Now, for the record, all these examples that I'm showing you right now, I'm not going to skip any steps, okay? I'm going to make sure you are all with me. There are some places where you can skip a step if you're comfortable with it, but in my examples that I'm going to show you today, I'm not going to skip any steps. Got it? Okay, what do I do here? Distribute, right? 4x plus 24 equals what? 10x. And now solve, right? So subtract 4x from both sides. 24 equals 6x. So dividing both sides by 6 gives me x equals 4. Is that the right answer? Are you positive? Could you be positive if you weren't to begin with? How? Plug what in? Oh, plug the 4 in. Okay. 4 over 2 times 4, 8, equals 5 over, God bless you, 4 plus 6. 4 over 8 equals 5 over 10. So they both simplify to 1/2, right? Could we use cross multiplication a check? 40 equals 40. Yeah? You good with that? So this is the right answer, and I'm positive of it, right? Okay. Any questions on that first example? Okay. What about this example? How do you solve an equation when it's two fractions set equal to each other? Okay, so we're going to practice that again because I only heard one person. How do you solve an equation when it's two fractions set equal to each other? Good. Okay, I just want you to be confident. Is that fair? Okay, so we have x minus 5 times 2x plus 7 equals x times x minus 1. Now, I did something on purpose, and I want to make sure you understand, excuse me, understand what I did and why I did it on purpose. Okay? So do you have this written down? Okay, I'm about to move the paper. Okay, so right now I multiplied these two and wrote it right here. And then multiplied these two and wrote it right there. You okay with that? But look what I did on this first example. I multiplied these two and wrote it first. And then multiplied these two and wrote it second. Can you tell me what point I'm trying to make? It doesn't matter which one goes first and which ones go second. Now I can't multiply these two, can I? Because first of all, that wouldn't be cross multiplying, would it? Okay. We multiply numerator, denominator, opposite ones. But it doesn't matter which one I write first and which one I write second. I could have written x times x minus 1 first, and then x minus 5 times 2x plus 7 second. That doesn't matter. Are you okay with that? Okay, let's keep on going with this problem then. So 2x squared plus 7x minus 10x minus 35 equals x squared minus x. We good? Now what? Combine like terms? These two? Okay, so 2x squared minus 3x minus 35 equals x squared minus x. Okay? Now what? So I'm hearing a couple things. What I'm not hearing is what I heard earlier. I want to make sure that you're okay with it. They said 2 times 35 is 70. negative 70. So it multiplies to be 70 and adds to be negative 3 because they were trying to factor this. Is it time to factor yet? No, because if I factor, all I'm going to get is that. And that's what I just multiplied out to get this, right? I simplified this out to get this so I can do what? What's my goal? I'm trying to solve for x, right? But I definitely want it to equal 0. Why do I want it to equal 0? What is this? It's a quadratic, isn't it? And typically with quadratics, we want to get them equal to 0. There's times when we don't, but typically we want quadratics equal to 0, don't we? So how am I going to go about getting this quadratic set equal to 0? So subtracting x squared and adding x. Everybody okay with that? So 2x squared minus x squared, negative 3 plus 1, negative 2x minus 35 equals 0. Now that it's equal to 0, what do I want to do? So some people want to factor, some people want to complete the square, is what it sounded like you were saying. Some people want quadratic formula. Is it all right if we just factor it? Okay, because I can, right? We can see pretty easily that we can factor this. Can you or not? Yes? What two numbers am I going to choose that multiply to be negative 35 and add to be negative 2? Negative 7 and positive 5. Now, if you want to use quadratic formula and complete the square, you go right ahead. Okay? But to me, factoring was easier on this problem, so I chose to follow those people that said that. Is that okay? So what's left to do? Yep, set each one of them equal to 0 and solve, right? Add 7, subtract 5, x equals 7, and x equals negative 5. Are they the right answers? They're not? Oh, we should plug them in, right? But before I even plug any of them in, I need to think about this. What are the possibilities? Could they both work? Yes. Could only one of them work? Yes. Could neither one of them work? Yes. All of those are possibilities, so keep your mind open for this, okay? All right, let's see. 7. 7 over 2 times 7, 14 plus 7, 21, right? And then 7. 7 minus 5, 2, and 7 minus 1. Is that true? 7 over 21 simplifies to 1/3. 2 over 6 simplifies to 1/3. Could we also cross multiply to check? 42 equals 42. So 7, I know it's small at the bottom, but for sure 7 is an answer, correct? Okay. What about negative 5? All right, negative 5, 2 times negative 5, negative 10 plus 7, negative 3, right? Negative 5 minus 5, negative 5 minus 1. Is that true? 5 over 3 equals 5 over 3, right? Okay. Or cross multiplying 30 equals 30. That means 5 is also a correct answer, isn't it? All right. Any questions about those two problems? Good so far? Okay. Let's look at this problem right here. 2 over 3x plus 1 over 6 equals 4 over 3x. 2 over 3x plus 1 over 6 equals 4 over 3x. Now, so we cross multiply? No? When's the only time we're allowed to cross multiply? Two fractions set equal to each other. There's more than two fractions, right? There's 3 fractions. Now, just like the last type of problems, there's several different ways to do this one. Okay? I'll show you as many ways as you want, but I think after I show you the first way, you're not going to want another way. Okay? if you had a choice, I want you to make a decision and like show me proof. So I want you to raise your hand or not. Okay? Show me by a show of hands. How many of you would rather not work with fractions if you had a choice? Everybody has their hand raised. Even me, right? All of us would rather not work with fractions if we don't have to, right? So how about if I show you a way to do this problem where you don't even have to work with fractions? You okay with that? Okay. Then we need to get some steps going. Okay? We need some steps. Here are our steps. Step number 1. What's step number 1 always? Don't panic. Now, sometimes people have a tendency to panic here because it's not two fractions set equal to each other, and they're like, oh, I know how to do it that way. I don't know how to do this way. You will. You're fine. Okay? Step number 2, find a common denominator. Okay? Find a common denominator. So in this particular problem right here, what would be our common denominator? Close. That's part of it. What else does it need? It needs an x, right? It needs a 6 because of the 6 and the 3. If that was the denominator, then yes, for sure, 6 would be our denominator, okay? Because you're remembering from yesterday where we said it has to be at least as big as our biggest one, if not bigger, right? Well, 6 is kind of the biggest one, but both of these have x's, so that also has to be part of the common denominator, okay? So 6x. But here's where things from yesterday are going to be a little different. We're not going to get a common denominator. We found it, and now we're going to use it. Step 3, use it to eliminate the denominator. So in a way, we are becoming denominator assassins. But that's not illegal. Only denominator assassins is not illegal. Regular assassins, that's illegal. So I don't want you to be a regular assassin, just a denominator assassin. Is that okay? Okay. So here's what I mean by use it to eliminate the denominator. What did we decide the denominator was? Common denominator? 6x, right? Okay. What am I allowed to multiply an equation by so I don't change its value, but it can help? Anything, right? As long as I multiply the whole entire equation by the same thing, that's not going to change the value of it, right? I'll still get the correct answer. I can't just multiply one part by it because that changes. I can't just multiply one side by it because that changes, right? But if I multiply the entire equation like this by 6x, whoops, 6x, that should work, right? This can be confusing. I wrote it for you on purpose so that you could see what we're actually doing, okay? But when we write it, when we do our work, I would prefer us to do this. 6x, 6x, 6x. Do you see how those two things are the same? Because basically I just distributed a 6x to each term in the equation, right? We're going to want to write it like this, and I think you'll see why in just a second. Okay? We want to multiply each term by 6x. So in the first fraction, what happens? Can I simplify these x's? Because they are factors, right? Nothing's being added or subtracted to them. Everything's being multiplied, right? So I can eliminate that x. What else can I do? Yes, Genevieve, I can simplify the 3 and the 6. This is a 1, this is a 2. You guys didn't hear, I could hear. Well, I could see her fingers. She was showing me what to do with her fingers. Okay? So after all that's left that I just did with the first fraction, what is left? So 4, right? 2 times 2, and then a 1 and a 1. Oh, there's also a 1 up here from the x's, right? But regardless of all that, 2 times 2 is left, and I'm just left with a 4. That's nice, huh? What happens here with the second fraction? Same thing, 6's cancel. Well, let's use better vocabulary. 6's simplify to 1, okay? What's left? 1x. Can I just write x? Are you okay with that? Okay. And what happens with the last fraction? X's simplify to 1. 6 and the 3 simplify to 2 over 1, right? So what's left in the third fraction? An 8, right? We've got the 4 here and the 2 here. So if I give you that problem right here to begin with and I said, you have a choice. You can either solve that problem or you can solve that problem. I think it's pretty obvious which one you choose, right? Okay. We used the denominator to eliminate the denominator. Use the common denominator to eliminate the denominator. You okay with that? Now to solve this, what do I have left to do? Literally just subtract 4, right? X equals 4. Is it right? Well, we should check, right? Okay, so 2 over 12 plus 1 over... Why did I write 16 and when I said 12? How do I even do that? Oh my gosh, that's so weird. 6 equals 4 over 12. So 2 over 12 plus 2 over 12 equals 4 over 12. Done. I know that that is the correct answer, don't I? How do you feel about that? So tell me what you think is going to be the hardest part about that. That's what most people think is the hardest part, is finding the common denominator. But remember, we spent all day yesterday working on finding a common denominator. Okay? The difference from yesterday to today is that yesterday we found a common denominator and got everything in that denominator, right? Today we're finding a common denominator and using it to eliminate the denominator so we don't have fractions to deal with anymore. Okay? All right, one more example. You ready? 10 over x squared minus 2x plus 4 over x equals 5 over x minus 2. 10 over x squared minus 2x plus 4 over x equals 5 over x minus 2. So yesterday, when we were working on our work, before we tried to find a common denominator, what did we do with the denominators first? If they weren't already, didn't we factor them? Because sometimes factoring them will help us see the common denominator better, right? Well, that's as far as it can go, right? That's as far as it can go. Is this as far as it can go? No, what can you do with this one? They both have an x, right? I can factor an x out of each term. Now is a little bit easier to see the denominator. What do you think the common denominator in this problem is? So x times x minus 2, right? It's not just the x minus 2 because remember I can't simplify this with an x minus 2, can I? Okay, so x times x minus 2. So every term I'm going to multiply x times x minus 2. So we found a common denominator and then we're using it to eliminate the denominator. Okay? So what happens in this first fraction? We're not really looking at that because we already factored it with this down here, right? What happens in this first fraction? What does? The x's simplify to 1 and the x minus 2 simplify to 1, right? So what's left? 10. That's it. Isn't that nice? What happens in the second fraction? Which ones? Oh, okay, so not this one? Okay, so this simplifies with this. That simplifies to 1. So what's left? 4 times x minus 2, right? Because this is a 1 now. So I have the 4 times x minus 2. And remember I told you I'm not skipping steps. This is a step that some of you can skip if you want. You can go ahead and multiply this out in that step. I'm just not going to today. Okay? And then what happens here? X minus 2 is simplified to 1. And what are we left with? 5x, right? Okay. So what do I do now? Distribute, okay? So 10 plus 4x minus 8 equals 5x. So 10 and negative 8, 2. 2 plus 4x equals 5x. Subtract 4x from both sides. 2 equals x. Is it right? We should check. Okay. Let's see. 10 over 2 squared minus 2 times 2. 4 minus 4? Uh-oh. Is that allowed? I'm surprised I was even able to write this without my paper catching on fire. Right? We're not allowed to have zeros in our denominator, are we? Does it matter what the rest of this equals? I mean, we can write it. 4 over 2 plus, equals 5 over, but look what I get again. This is not allowed. I even wrote it 2 times and still no fire, right? But what do I do? What do I write? This does not work. Did I do anything wrong in my arithmetic? No. Just the way that the problem was set up, the numbers that were used, the way that it all worked out, I got a number that made the denominator of the fraction equal to 0, and that not allowed. Your paper caught on fire? Okay, don't write it then. Okay. We're good? Any questions? Tell me the steps again then. Step 1, don't panic. Step 2, find a common denominator. And step 3, very good. Eliminate the common denominator. Assassins of denominators. Only denominators. Got it? Peace.